learning theories and concepts from knowledge to practice. Behaviorism, reinforcement, positive and negative. Reinforcement is a process that increases the recurrence of a targeted desired behavior. For it to be effective, it must be implemented with fidelity and in a timely manner. There are two different types of reinforcement. Positive reinforcement, which is the added of a desired stimuli to promote a desired behavior. These can be both tangible, such as stickers, candy, or toys, or they can be intangible, such as verbally acknowledging the completion of a task. Negative reinforcement is the removing of an unpleasant stimulus to promote a desired behavior. Example of this could be removing homework or quizzes for following class directions. One common misconception is that negative reinforcement is the same as punishment. This is false. Negative reinforcement seeks to increase a behavior by removing an undesired event. Punishment seeks to decrease a behavior by adding an unwanted event or by taking away a desired one. An application of positive reinforcement is in establishing classroom management. A targeted area could be work completion. An example of this would be students receiving tickets for properly completing their work. At the end of the week, students could exchange these tickets for prizes such as homework passes, computer time, snacks, or even lunch with a teacher. This specific type of positive reinforcement is called token reinforcement. Token reinforcement is a system where individuals earn tokens for exhibiting desired behaviors, and these tokens can then be exchanged for various rewards or privileges. In this example, the desired behavior is the student's proper work completion. The desired stimulus is the opportunity to acquire tickets. Now we will use the same application of classroom management and work completion, but we will apply the concept of negative reinforcement. In this example, when a student completes his or her classwork properly, he or she will be exempted from completing a quiz. In this example, the desired behavior is still the student's proper work completion. The undesired stimulus being removed is the completion of the quiz. Behaviorism, fixed reinforcement schedules, ratio, and interval. Fixed means that reinforcement schedules occur at consistent intervals. There are two types of fixed reinforcement schedules. Fixed ratio schedules deliver the reinforcement stimulus after a set number of responses or instances. Fixed interval schedules deliver the reinforcement stimulus after a set amount of time. Fixed schedules are more predictable than variable reinforcement schedules. Variable schedules deliver the stimulus after a varying number of instances or time. One classroom application of a fixed ratio schedule is the facilitating and establishing of good instructional practices. A specific example is rewarding students for passing and completing iReady lessons. The teacher will give students a sticker for every 5 lessons they pass. The students will then put these stickers on a chart to track how many lessons they pass in a school year. The example of the fixed ratio schedule is the 5 lessons passed. The example of the reinforcement are the stickers the students receive. With the chart being visible to students, it keeps them focused on the expectations and goals that have been set for them. Fixed interval reinforcement schedules. One application of this concept is through assessment. A specific example is giving a weekly spelling test to students. Students receive a grade for their weekly spelling test. The fixed interval in this example is the fact that the spelling test occurs on a weekly basis. The reinforcement in this example is the grade the students will receive on their test. This reinforces the students studying and doing well on the test, as their reward for knowing the spelling words is a good grade. Human cognition, retrieval-based learning. Retrieval-based learning is a strategy that focuses on actively retrieving previously learned information. Concepts to consider. One concept of retrieval-based learning is active recall, which strengthens memory as it requires students to actively pull information from their memory. Another concept of retrieval-based learning is retrieval practice. This enhances long-term memory by actively recalling information from memory rather than simply rereading or passively viewing it. The final concept of retrieval-based learning is desirable difficulties. This is a crucial step for students to encounter as it ultimately leads to better long-term memory retention. Desirable difficulties intentionally create a degree of challenge for students. Rather than creating frustration, when implemented properly, these difficulties result in deeper understanding through processing and memory formation. Retrieval-based learning offers many benefits to learners. One benefit is the enhancement of long-term retention. This is because actively recalling information creates more neural pathways and connections, which makes it more difficult to forget information. Retrieval-based learning is much more effective than merely rereading, as it forces learners to actively engage with the information. Another benefit is improvement of understanding. This is in large part to the fact that it forces learners to apply the information to new situations and problems, thus increasing understanding. Furthermore, students become better problem solvers. A third benefit is better metacognitive awareness. When learners must retrieve the information, it makes them aware of their strengths and weaknesses. This means that they are more aware of how they think and learn, which promotes better learning strategies. One application of this in math class is to promote fact fluency. A specific example of this is having students create flashcards with their math facts on them. The students can then use these flashcards to help them retrieve the information. There are several benefits to this concept. Firstly, it encourages active recall. Secondly, it promotes long-term retention. Lastly, it utilizes a prompt answer format. Human cognition chunking. The term chunking refers to an instructional technique where teachers break apart more complex concepts into easier understand chunks. Concepts to consider. To be effective, the content must be broken into meaningful parts. When used properly, it results in improved retention of information. It also results in better student cognitive processing. Chunking is a flexible concept that can be applied to many different fields. One application of chunking is solving multi-step word problems. An example would be to have the students break the different steps into chunks to make problem solving easier and more effective. Firstly, the students will read the problem. Next, they will break the problem apart. Then, they will solve each part. Lastly, they will combine solutions to find the final answer. Motivation to learn. Doing just enough goal. The doing just enough goal is a strategy where one sets very minimal, easily achievable targets to encourage consistent progress and build momentum without the pressure of long, daunting goals. Concepts to consider. Goals should be so easily achieved that it's almost impossible to fail. When goals are easily achieved, it gives an immediate sense of accomplishment. These small successes also build confidence. As these simple goals are reached, it makes it easier for the learners to attempt more challenging goals. Completing tasks successfully sets a new standard that facilitates better habits. Focusing on smaller tasks keeps learners from feeling overwhelmed. This avoidance of feeling overwhelmed prevents burnout and fosters a better work ethic. One classroom application of this concept is to promote student motivation. A specific example would be to motivate students who struggle and become overwhelmed with classwork. For these students, setting a doing just enough goal of completing all classroom assignments would allow them to focus on smaller tasks. Benefits this example provides are focusing on smaller goals lowers the pressure on students. This will reduce anxiety and prevent burnout. Over time, the continuous completion of smaller tasks builds a better work ethic in students. When students begin successfully completing tasks, it acts as positive reinforcement. The intrinsic motivation the students feel reinforces the drive to complete more tasks. Motivation to learn. Expectancy value theory. Expectancy value theory suggests that an individual's belief that they can or cannot succeed at a task drives their motivation in completing the task, and thus the value they place on completing it. Important components. The expectancy for success refers to an individual's confidence in their ability to complete a task successfully. Importance relates to the personal significance of the task and the value an individual places on doing it well. Utility is the perception of how useful the task will be for future goals, tasks, or careers. Interest is the intrinsic value of a task and reflects the enjoyment and pleasure that comes from taking part in the task itself. Cost refers to the sacrifices associated with engaging in the task. Example of this are effort, time, and other opportunities an individual could not engage in. An application would be to promote motivation. One example when it comes to math is the student's motivation to study or not study based on their perceived success on the test. If a student feels that they are likely to fail the test, whether they study or not, then they are going to be less likely to study. This is why it is imperative that teachers set expectations that all students succeed. Benefits. This theory helps predict what individuals will choose to do based on their beliefs about their ability to succeed and the value they place on the outcome. It explains why some students are more motivated than others and how their beliefs about their abilities affect their academic success. It can even help us understand the factors that influence individuals' career choices. By understanding the role of expectations and values, educators can design interventions to increase motivation and encourage desired behaviors from their students. It also allows educators to create a learning environment that fosters a sense of value, leading to increased engagement and learning. Event 1. Gaining attention. Through gaining attention, teachers ensure that students are ready to learn the new material. For students to learn properly, their brain must be primed to receive the new information. Key concepts. The purpose of gaining attention stimulates student interest and sets a stage for learning. Some examples are asking students probing questions to build interest, offering surprising facts that pique interest, conducting icebreaker activities that let students experience the phenomenon before they learn about it, conduct experiments that demonstrate the concepts about to be learned. One application of this event is in the field of math instruction. The teacher could begin a math lesson on measurement with different ingredients needed to make a recipe and the current quantity of each. The students would then be asked how many recipes could be made based on the current quantity of ingredients. Benefits. When students are posed with a problem and must create a solution, it increases their focus on the new material. When students are unable or unaware of how to solve the problem, it increases their curiosity. Promoting real-world applications sets the stage for learning. Event 2. Informing learners of objectives. Teachers should communicate to students what they should be able to do and what activities they should be able to accomplish at the end of a lesson. Key concepts. Informing students of lesson objectives helps students focus on instruction throughout the lesson. Informing the learners also sets expectations of what will be required of the students after the lesson has concluded. Finally, informing learners prioritizes the attention they give to instruction. Should students not understand part of the lesson, it motivates them to ask questions to better understand it. One application of this event is in the field of math instruction. When teaching a fourth grade geometry lesson covering calculating area, the teacher should inform the students that the objective of the lesson is that they are able to calculate the area of a composite rectangle by the end of the lesson. This cues students that they, 1, need to know what a composite rectangle is, and 2, need to know what formula and steps are required to calculate the area. Benefits. By knowing that they are going to have to be able to calculate area on their own, student engagement will be increased because they understand the results they are working towards. This also provides a roadmap to success for the students, as they will be able to focus on each step in the process. Simply put, when students know what is expected, they will find more value and meaning in learning it. No one likes listening to a lesson when they do not understand why it's important. Event 5, providing learning guidance. When providing learning guidance, the teacher supports students by making sure they understand and know how to apply the new information. Key concepts. When teachers provide guidance to students, it increases the meaning of the newly learned information. Providing learning guidance to individual students creates scaffolding and learning, where students are given the support they, as individuals, need. Providing learning guidance also gives the teacher the opportunity to create real-world relevance and meaning for each student as it applies to them specifically. One application of this event is in the field of math instruction. One way that teachers can provide learning guidance to students is through the implementation of anchor charts in the classroom. Since they know their students, they possess the ability to create anchor charts that meet the needs of all students. Benefits. Since the anchor charts are displayed where all students can see them, it makes the content available to students as needed. Displaying anchor charts also increases students' retention of the new material, as seeing them on a daily basis creates more neural pathways in the brain, thus resulting in better retention and understanding. Most importantly, it creates learner independence. When students can access the information as needed, it facilitates their independence to take responsibility for their own learning. Event 8, assessing performance. Assessing performance occurs when the instructor implements assessments to evaluate the extent of student learning. The implementation of assessments should be a mixed methods approach, meaning it should use both qualitative and quantitative data to get a complete look at how well the students understand the material. Students can create a project that demonstrates their understanding of a specific math concept, such as building a model of a geometric shape to illustrate volume, or creating a presentation on the impact of compound interest. Students can present their mathematical findings, such as analyzing data or problem solving, using various tools like PowerPoint or other presentation software. Students can use the standard algorithm to solve math problems relating to the newly learned material. One application of this is in the field of math instruction. A specific example of this is a teacher assessing students on their understanding of fractions after completing a lesson or unit. Assessments provide many benefits to teachers. The most obvious benefit is that teachers get a better understanding of how successful students learned the newly taught material. Another benefit is that students are given a chance to solve more problems and interact with the newly learned material. This lets them assess their own understanding of the material. A third benefit is that teachers are provided with data that will help them plan their next steps to remediate and enrich instruction as needed. Social cognitive theory, self-efficacy. Self-efficacy is the confidence and belief one has in their ability to succeed at completing a certain task. There are 3 key effects self-efficacy has on behavior and cognition. The first is activity choices, which refers to the fact that people typically choose tasks they feel they have a high chance of being able to successfully complete. The second is goals. The higher an individual's level of self-efficacy, the more challenging goals they will set for themselves. The final effect is effort and persistence. People with higher self-efficacy are more likely to work hard to succeed in task completion. One application of this is in the field of math instruction. A specific example of this is a student's belief in their ability to successfully answer math word problems. The higher their level of self-efficacy, the harder they will try to solve the problems. This is why it's critical that teachers help students build their self-efficacy. There are 3 factors that influence the development of self-efficacy. The first is an individual's previous successes and failures. The more successful an individual has been at completing a similar task, the higher their level of self-efficacy. Conversely, the less successful an individual has been on completing a similar task will result in a decrease in self-efficacy. The second factor is their current physiological state. If an individual is well rested and in a clear state of mind, the higher their level of self-efficacy and confidence. The final factor is messages from others. Many people have a higher level of self-efficacy when they feel others have confidence in them as well. When teachers praise their students for their successes, it increases student self-efficacy. Social cognitive theory modeling. This refers to a learning process where individuals acquire new behaviors, thoughts, or emotions by observing and imitating others, known as models. This can refer to what the model or teacher is doing, or could refer to what the observer or learner is doing. Proper modeling impacts and affects behaviors. Learners can develop new behaviors through the observation of others. Individuals are more likely to display previously learned behaviors when they see others being reinforced for the same behaviors. If individuals see others engaging in forbidden behaviors without negative consequences, they may be more likely to try them themselves. When a given behavior is modeled, the observer may display a similar behavior rather than the same exact behavior. One application of this event is in the field of math instruction. An example of this is modeling how to use scratch paper. When learners see the teacher using scratch paper as well, they are more likely to mirror that behavior and use it themselves. Keys to successful implementation. Models must display competency in their behavior. Observers are more likely to emulate the desired behavior when they feel the one modeling the behavior has knowledge and skill. Learners are more likely to model the behaviors of individuals who are viewed favorably in societal settings, such as the school or community. Models that display behaviors that are normal of their gender stereotype are more likely to influence behaviors of that gender. Male models influence male behaviors, and female models influence female behaviors. Learners are more likely to model their behaviors when they view them as important and relevant to their own lives.